where you can't use the calculator. And you have to earn those points algebraically. All right, now formula looks pretty nasty. F of x times g prime of x plus g of x times f prime of x. In words, this is the way I learned it. The first function times the derivative of the second, so first times the derivative of the second, plus the second times the derivative of the first. Basically, you're taking the derivative of each part, but you're also leaving each part in its original form, multiplying them in every possible arrangement, and then adding the results. All right? But when I say it like that, it sounds confusing. The first function, the first part of the product. The second function would be the second factor in the product, the second part of the product. So if I'm going to differentiate using the product rule, and again, differentiate is just another word for derivative, I'm going to take my first function and leave it exactly as it is. Then I'm going to multiply by the derivative of the second function, which is going to be what? 3x squared. Then I'm going to add to that my second function in its original form and multiply that by the derivative of the first function, which would be what? 6. Now, you just got to be careful of instructions. I don't like doing this too frequently, but for definitely one problem on the test, it won't just say differentiate, it'll say differentiate and put your answer in simplest form. Simplest form means you got to clean this up. Differentiate means you don't have to clean it up. All right? If you see just these instructions, leave it as is and move on to the next question. If it says and simplify, then you want to distribute it out, combine like terms, see if you can factor it in some meaningful way, and then go from there. All right? In this case, I don't know how meaningful it would be to distribute it out, so I don't really feel the need to do it. And besides, the directions didn't tell us to do it anyway. But you should be prepared on the test at least or exactly one time to have to clean it up. All right? But I would even say for a simple algebraic case, I wouldn't expect that to happen. You got to think more like trig or exponential log situations, because those are the ones that can kind of clean up nicely. I don't know, for example, if I saw a question, I highly recommend that. All right, so we have two functions here. I'll use the same color scheme, but I'm going to rewrite the first one just to make it a little nicer. Instead of having the square root of x, I'd rather write that as what? X to the 1/2 All right, so we have our first function and we have our second function. So using the product rule, I take my first function, just the way it is, unaltered, multiply it by the derivative of the second function. What's the derivative of the second function? Cosine of x. Plus, I leave the second function just the way it was originally, multiply by the derivative of the first function, which would be what? 1/2 x to the negative 1/2. All right, so just by looking at this, you don't even have to take it the next step to realize that it's going to be much more challenging to simplify something like this than it would be to simplify something like this. All right. Down the line, and I'm thinking like next unit, you're going to naturally have to simplify stuff like this, not because I'm going to tell you to, but because you're going to need to use this for something, like applications, word problems, things like that. maybe even finding, and we'll do a little bit in this unit, but like finding a second derivative, which is the derivative of the derivative. Sometimes cleaning it up makes the next derivative in the process a little easier to handle. So that would be a choice on your end. Because the way it stands right now, if I had to take the second derivative, the derivative of this, I have product rule, and then put it all together, it's gonna be a mess, all right? So I might make the choice to simplify to meet my own needs, but not because I'm being told to, all right? So number 3 is one of those problems where you could use the product rule. I got a first function and I got a second function being multiplied. So I could go dy dx, just different notation for derivative. First function, the way it was originally, times the derivative of the second. What's the derivative of cosine? Negative sine of x. Plus the second function, so cosine of x, times the derivative of the first function, which is what? Cosine of x. All right. If I'm going to ask, I said this before, if I'm going to ask you to simplify, it's probably going to be for a question like this. Because if I multiply the first two parts together, I get negative sine squared x. Multiply the second two parts together, I get cosine squared x. Rearrange, I get cosine squared x minus sine squared x. There's a simpler form of that, we just talked about it. Cosine of 2x. If you don't know that double angle identity, you don't get that. Of course, I'm not going to, I mean, if it's a 5-point question, I'm not going to nail you for like 3 points on it just for not getting that last step. You'll lose half a point, maybe a full point. So it's not going to be the end of the world, but they're points, and you don't want to give them away. Now, an alternative approach to a question like this would keep you from having to do product rule at all. So let's say, I'm taking it from scratch, and I remember my double angle identity for sine. Sine of 2a is equal to 2 times the sine of a times the cosine of a. All right, do a little comparison here. So I'm comparing this one to this one. What's the difference between the two? There's no 2, right? So everything else seems to be in order. If I were to chop this in half, I'd get this, yeah? Roughly? Just replacing the a's with the x's?
So you just put sine to a again?
Sine, well, yes, let me just get a pen. So sine of 2a, instead of writing it as, oh, not 2a though, we're going to say 2x. Instead of saying it over 2 though, let's just say 1/2 as a coefficient. Same thing, just puts it in a nicer format. The reason this is going to be a little better for us is anytime you have a constant multiplier, we know that that's just going to carry right down into the derivative, right? So we don't have to worry about that. I know if I have a 1/2 as a constant multiplier in my original function, I'm going to have a 1/2 as a multiplier in my derivative, all right? So I don't have to worry about that part. It's just a matter of worrying about what's going to happen here. So dy dx would be equal to 1/2 times, and what is the derivative of the sine of 2x? Fluency. 2 cosine 2x, or cosine 2x times 2. I think I heard that one also. All right. Then the fraction, the 1/2 and the 2 cancel out, and we have our cosine of 2x. In either case, you need to know an identity in order to get the simplified answer. just a question of, you need to know it at the end or in the beginning. This way requires you to use product rule. This way you can avoid using product rule. So, it's strengths and weaknesses. You know, you might look at this and say, well, I didn't remember what the derivative of sine of 2x was, so this is out. Here you didn't have to worry about it. You know? If you hit a roadblock in one or using one technique, go to another.